Okay, we got a couple more examples here for our three types of problems with the work, the mixtures, and the distance. So we'll start here with this one here. All right, Mia adds a 70% acid solution to 12 milliliters of a solution that is 15% acid. How much of the 70% solution should be added to create a solution that is 60%? So as we're working through this, same kind of deal here. We want to set up a little chart, if you will, to get our stuff organized. So we're going to have what we started with, so we'll call it the original. We're going to add something to it, and then we'll get a total out of this. So let's see what's going on here. We got a solution. Part of the solution's acid. Okay, 70% of it is acid of the 12 milliliters. The rest of it is base, inert, water, what have you. So we've got the acid composition, and then we've got our total solution. So let's go with our original. Our total solution, as we're working through this, is what? 12 milliliters. That's acid and water, I guess, together. So how much of this is acid? 70%. So let's just set it up. I know some of you will jump to the gun here and go to it. But now, hang on one sec. All right. My little misinterpretation here. This isn't 70% this. It's a 15% of this. So again, I misread. We had a 70% that was being added to a 12 milliliters that is this much acid. So as you can see, take your time reading these so you get them set up right. So we have 12 milliliters of something. It's acidic. It's 15% acidic. So 0.15 times our 12 milliliters, that tells us how much of it's going to be acid. Okay, so now we're adding a 70% acid solution to it. Keywords right there that I missed. How much of the 70% solution should be added? Well, we don't know. We're asking how much. So how much is being added? This much is being added. How much of what we're adding is acid? 70%. So what do we have going on here for a total? Well, we had some. We added some more milliliters, so we got 12 plus X right there. Of what was already in the beaker, let's say, this much of it was acid. So we take, we take 0.15 times 12, and we get 1.8 plus that much more acid, if you will, in our solution. So the question is, what do we want? Well, we want a solution that is 60% acid. So again, we don't know how much. We know we want 60% acid. So what we want over total. We want this acid. That's what we want. How much acid? So 1.8, I'm sorry. Plus 0.7x, what we want, figuring out how much, over our total. Now, you can say what we want, or we can say acid out of the total. How much of it's acid? Total. We want 60% acid out of a total. A couple different ways you can look at it there. So let's get to work. We can do a couple things here if we like. A very quick reduction. We could go 6 out of 10. You can reduce that down to 3/5 if you'd like. Why am I sticking with 10? I'll show you here in 1 second. Because I notice there's decimals in the problem. So by leaving 10, I can pretty much guarantee at least one of the decimals gone, if not more. So let's do our cross products. That's going to give us 18. And then don't forget there, plus 7x. Cross products there. Equal to 72 plus 6x. And again, I noticed that the decimal point will be gone with 10, so I didn't reduce it all the way down to 3/5. All right, so let's work. As we work through this, we can see that subtracting 6x from both sides will give us x here. Subtracting 18 from both sides will give us 54. So what do we need here? So what's this mean? We need 54 milliliters of the 70% solution to be added. That'll give us what? A solution that is 60% acid. That's what we're looking for. So, we'll have 66 milliliters of it, but it'll be that 60% acid mixture that we need. Okay, so now let's look at a distance problem. And remember, we can manipulate distance, different ways of whatever variable we're trying to solve for, d, r, or t. So you got the speed of wind is 20 miles an hour. So you got a 20 mile an hour wind going on. If it takes a plane 7 hours to fly 2,368 miles round trip, that's there and back, determine the plane's speed in still air. So if there was no wind, how fast would the plane be going? So what do we know here? The total trip, our time, is 7 hours. We don't know a rate, although think about it. If I'm going into the wind, in theory, we're going to be flying slower. Not in theory, you will be. We go with the wind, you'll be flying faster. So the rate might change a little bit in those categories. And we got a total distance here. That's round trip. So we know how far it is both ways. So our setup is probably going to look something along those lines. So what do we know? Well, one way is 1,184 miles. Headed one way. And it's going to take us 1,184 miles to come back. Again, though, one's going to take a little bit longer than the other. We know it's a total of 7 hours. So one way we could set this up is we could go time with the wind and then time against the wind. That's going to do what for us? Give us our total time. So however long it takes to go with the wind, which should be faster, however long it takes to go against the wind, gives us our total time. So what's our total time? 7 hours. We've got a distance, 1,184 miles. Still 1,184 miles. Now it's all about our rate. So if we're going with the wind, what's that going to do to our rate? It's going to increase it. So we don't know how fast we're going, but we're going to have a 20 mile an hour tailwind with us. So it'll add 20 miles an hour to our rate. When we're going against the wind, That's going to slow us down by what? 20 miles an hour. So we've got our chart, we've got our data, we've got our information set up. So let's see what we have. 1,184 over r plus 20 plus 1,184 over r minus 20 equals 7. You want to put it over 1 to look like all the rest? Be my guess. So what are we going to have to do here? We are going to have to do a little LCM or LCD. And that's going to be what? Well, there's one factor. There's one. Not going to change anything. So an r plus 20 and an r minus 20. So r plus 20, r minus 20, and we're going to multiply them by one fraction, two fractions, three fractions. So r plus 20 cancels out, r plus 20 cancels out. So that's going to give us 1,184 times r minus 20. R minus 20, r minus 20 cancels out. Plus 1,184 times what? R plus 20. Over here, nothing cancels out. 7 times r plus 20 times r minus 20. Okay. So let's figure out what we got to do. And that is distribute 1,184 r minus 23,680 plus 1,184 r plus 23,680 equals sum times the difference, r squared minus 400 gives us 7 r squared minus 2,800. Okay, let's start getting rid of some things here. Gone, gone, and we have 2,368 r equals 7r squared minus 2,800. So as you notice, we have a quadratic equation, so let's set her up. 7r squared, bringing that over, minus 2,368r minus 2,800 equal to 0, standard form. Okay, so let's work. Let's face it, this isn't going to be one we get to factor. It's not the best. You may want to try to factor it. I probably wouldn't recommend it. So what are we going to do? Quadratic formula. Opposite of b, plus or minus square root minus 4ac all over 2a. So let's set her up. B, opposite, so positive 2,368 plus or minus. Yep, that's going to get big. Negative 22368 squared minus 4 times 7 times a negative 2,800 all over 2 times 7. So here we go. So I'm going 2,368 plus minus big old square root. We know it's going to be over 14. Busting out the calculator. We'll have 2,368. Clear the calculator. Squared, that's about 5,607,000 Now, negative, positive, negative, so it's going to be plus 28 times 2800. So underneath our radical sign, we will get 5,685,824. So we're going to take the square root of that bad boy. And when we take the square root of it, 2,368 plus or minus, excuse me. And I'm going to the nearest tenth right now, 2,384.5 all over 14. So now let's use some logic. You're going to take 2,368 and add it to this. You're going to take 2,368 and subtract this. Well, that's bigger. So the negative won't work. So let's not even waste our time with that. Not even going to waste our time with that. So, again, we are calculating. So we are taking our 2,368 and we are adding to it 2,384.5. And we should get 4,752 and a half. Divided by 14. And we get, let's go to the nearest hundredth, tenth. Yeah, let's go hundredth. What the heck? 339.46 miles per hour. And what is that? That's the speed of the plane. In still air. Speed of the plane in still air. Okay, our third example then that we have will be a work problem. So you got a painter, and they can paint a house in 12 hours, one person. Okay. Second painter, maybe they're more experienced, can paint the house in 8 hours. How long would it take to paint the house if they both work together? So, like before with a work problem, we want to set up as a rate. This person can do how much of the job in 1 hour? Well, if it takes 12 hours, in 1 hour, so we'll call it painter number one, in 1 hour, they do 1/12 of their rate. 12 hours to do the job, 1 hour, I've done 1/12 of the work. Painter number two, because we're going to work together, can do the whole job by themselves in 8 hours. So in 1 hour, how much of the work do they get done? They get done 1/8 of the work. They're going to work together, and again, that's a rate of what they can do in 1 hour, what they can do in 1 hour. We want to know what their rate together is. So 1 hour over X, Y, W, W for work. Okay, so we begin again. What do we got going on here? Well, we're looking for an LCD. I know I've been using LCM quite a bit. It's the least common denominator that we're working for. Now here, you get a little bit of a luxury. You can see what 8 and 12 both go into. But we also have this other factor over here. So we're going to get a 24W as our LCD. So let's try it out. So 24W gets multiplied by all this. 12 cancels into 24, 2W. 24W, 1/8 cancels 3 plus 3W equals 24W times that, the W's cancel. 24. So, as we continue working through this, we see that 5W equals 24 divided by 5, and W will equal 4.8. Means what? One person did it in 12 hours. One person did it in 8 hours. Together, they can paint the house A-I-N-T, there we go. In just under 5 hours. So 4.8 hours. So the work problems, again, set up a rate, 1 hour, how much of the work, and then together. And there you have your third example.